Hello all, my name is Ty and I'm one of the head TAs for Code in Place. I wanted to take a couple of moments and address some common questions I've been asked during office hours. Each section leader that attended office hours, especially those who attended following their first session, had these questions. But because I recognize that not everyone can attend office hours, I thought it might be of some value to all of you to address these concerns in a way that could be disseminated widely and viewed at your convenience. I really want to talk about a few main things. Should I go straight into coding or should I break the problem down first? If I'm supposed to break the problem down, how exactly do I go about doing that? And another question people have had is, how do I adjust my teaching for the various skill levels in my class? I'll address the latter first. Okay. The TLDR answer to this question is simple. You don't. Remember what Code in Place is. It's an offering of a first-year Intro to Python course, CS 106A. I don't know about all of y'all, but when I took my first programming course 4 years ago, Intro to Java, I had no idea what it meant to write code at all. I needed to be taught all the foundational concepts, and I needed the patience and the understanding of my instructors that I was a new learner who was learning a really complex thing. And I think for a lot of us, coding comes naturally. It's almost like a second language, right? And that's not the case for everybody. So it's important to remember that we're teaching for the beginner because that's the most inclusive way to teach. So when students signed up for Code in Place, Chris and the staff, to the best of my knowledge, selected for people with the least experience possible. So the far along student is the exception, not the rule. And the hard thing about that is because the far along student is often bored by initial concepts and because they have an understanding of these initial concepts already, sometimes they can be the first to answer questions in a group setting or the first or sometimes the only people to offer solutions. We don't want to discourage their participation. So what do we do? Well, largely that is going to be at your discretion as the section leader. You have to develop an understanding of the different personalities and learning styles of the people in your classroom. However, I think I can give you a couple suggestions that might make engaging everybody a bit easier. The first one is use breakout rooms. I know that for some people, it can feel like breakout rooms are a welcome for awkwardness. But I think that for a lot of people, the number one fear that they have is public speaking. And even though we're not in person, right, people are still talking to a large group of people that they don't know. And often, especially if you have a couple accelerated students or especially outgoing students, that exacerbates the fears of other people who may be afraid to speak up in public. So breaking down into these smaller groups and analyzing the problem piece by piece, maybe assigning each small group a portion of the problem and then coming back as an aggregate and going over the problem in totality, makes it far more likely that you're getting input from everyone. Another thing is ask open-ended questions, which kind of goes without saying, but I'll say it anyway. When you leave open-ended, or when you ask open-ended questions, you allow room for a lot of different perspectives. Additionally, you give yourself the ability to continue, even if somebody else gives an answer that is satisfactory, right? You have the ability to continue by saying something like, who else has a strategy that they might want to employ that's a little bit different? Or what happens when we follow X student's strategy through, et cetera, et cetera. And then another thing is to remember that the focus is not on answering the prompt in class. The focus during class is encouraging and developing those problem-solving muscles, those analytical muscles that we need in order to solve more complicated problems later down the road. So we don't have to be focused on jumping into the IDE and throwing some code in it to get a working answer. we are mostly focusing on the process of solving the problem. And how do we stay focused on the process of solving the problem? Well, we employ problem-solving techniques, which leads us back to where we began. Am I supposed to dive straight into the code? And if I'm not supposed to dive straight into the code, what do I do to keep from doing that? How do I do that? And there are a number of resources out there that you can use, that you can employ. Anybody who's talked to me for more than 5 minutes knows that the one that I'm going to share with you is my absolute favorite, but it's not to say that it's going to be your absolute favorite or the easiest for you to teach. But what I'm doing by sharing this is kind of just giving you an idea of a strategy that you can use and the type of strategy that you need to be looking for when you're looking at how do I extrapolate this problem? How do I keep from jumping straight into an IDE? So without further ado, let's take a couple of minutes and go through one of those. So my favorite problem-solving strategy is the umpire strategy. And obviously, or maybe not obviously, umpire is an acronym, and I'll go through each step. I'll go through each letter, excuse me, step by step. And at the end of this, you will have a completely solved problem, and it will be far more fleshed out, and you'll have an opportunity to get far more input from your classroom breaking down a problem this way. So the U in umpire stands for understand. And what does that really mean, right? Understanding means we read the problem statement as many times as we need to read it, right? So read the problem statement all the way through. Sometimes you'll need to read it twice. Sometimes you'll need to read it 3 times. Let your students dictate how many times you need to go through the problem statement. It's perfectly okay and perfectly reasonable if the first time you go through a problem, everybody doesn't understand every piece, right? So read it through and do that as many times as necessary. And then what we are doing in this step, and all we are doing in this step, we are not doing this in an IDE. We can do this on a whiteboard the way that I'm doing this. We can do this via call and response. We can do it in a breakout room. We can take 3 to 5 minutes in a breakout room and go through this step. But what we are doing is, if I give you a pen and paper, and of course this is virtual, right? So pen and paper and several different inputs. Can you identify the output? Right. And in the context of something that you might actually be teaching, how do we actually apply this to code in place, right? Hospital Carol has a very specific instruction in the problem statement that you have to come up with a solution that works no matter what your world is, right? So a solution that works, it doesn't matter if the world that Carol is in is 5 by 5, if it's 14 by 7, if it's 11 by 9, it doesn't matter, right? Your solution is applicable across worlds. So that is not to say that we reject a student's solution if it is only applicable to the current world, because that's important. We have to have a solution that's applicable to the world that we're working in. And then from there, we take that solution and we flesh it out and we try and work through with them, asking questions to figure out how we can make this applicable on a larger scale, right? So we want to make sure that we're really understanding the problem. What are the inputs that we're given? What are the outputs that we need? How do we get from input to output? And I should be solving this, and I being your students, should be solving this on quote unquote a pen and paper, not in an IDE. We shouldn't be coding just yet. The second step in Umpire is match. And at the beginning, your students aren't going to have anything to match. What is matching? Well, have I solved any problems before that I can apply to this one? Right? So obviously your week 1 students will not have ever solved any sort of problem. So they won't have any problems with which to match. But when you go from week 1 to week 2, you always make sure you take this step. Is there something about my solution to the last problem that can be applied to this problem? And what we're doing when we match is we are exercising that the muscle that will eventually become algorithm identification for problem solving, right? What algorithm do I need to apply to this problem in order to solve it? This is the beginning of developing that skill. So we want to make sure that we don't skip the matching stage. Then the third step is plan. And planning is where you write your pseudocode. And what I like to think of this step as is, right, this is where you are actually developing your algorithm. Your plan should be as close to directly translatable from English to Python statements or from English to Carol statements as possible, so that when you get to your fourth step, implement, you and your students have all but solved this problem, and you are translating your pseudo over to code, right? And the bulk of your time in class should be spent on these first 3 steps: understanding the problem, matching, have I solved any problems before that I can apply here, planning, writing my pseudocode, following my pseudocode through, trying to figure out what's going to happen when I ultimately implement this code, and then we are writing code, right? So you've spent a large chunk of time on these first 3 steps. And then probably by the time you get to implementation, you will be reaching the end of your class, especially in these beginning weeks. But the R in Umpire is review or revise. Choose a couple of variables once we get there. Track values. Debug, right? And this gives you an opportunity to make sure everything's working the way that you want it to work. And if it doesn't work, then we go back to our plan. What about our plan is incorrect? What can we, and not even necessarily incorrect, where is our opportunity for optimization? What can we change? What behavior is happening? And what controls this particular behavior within our code, and how can we manipulate that? And then the last step, and we probably won't start getting to this until the latter part of the course, is evaluate. How can I optimize my program, right? So how can I make this faster? And I suppose we won't be waiting until the end of the program, because we're encouraging using functions from the beginning. So the last step is to go back over and evaluate all the code you've written. Is there a way that I can make this faster? Is there a way that I can truncate this? Is there anything that needs to be encapsulated? Have I separated the things that are changing from the things that are not changing? And breaking your problem solving process down into these very defined steps gives you a very clear goal at each point, right? Which gives you an opportunity to give your students something specific to work on that does not, especially in those beginning stages, that does not require them to jump straight into their IDE, that kind of forces them to slow down a little bit. And that's how you keep yourself from jumping straight into code, because I know that the pressure can often be a little bit unnerving, to get started, to feel like you are active and engaged and having fun. And I think that breaking down these problems into pieces ensures that your students will stay engaged and have fun, and that your course can be interactive, and that your sessions can be dynamic and won't get stale or feel the same because your problem changes. So the way you move through those steps changes each time. This was a tad bit longer than I would have preferred, but I hope that I got you all some tips that you can use and apply in your classrooms before this coming Wednesday's course. And please, if you have any questions, if you need any help, if you need any tips, if you want to walk through your own teaching processes, sign up for one-on-one office hours. Sign up or attend one-on-one office hours, attend group office hours. Ask questions in the forum. We are here to help you and support you in whatever way we can. Have a wonderful day. Thank you all for listening to me. Bye-bye.